Alrighty, welcome to the 2021 Virtual Christmas Summit. It's brought to you by Boscoyo Studio. This presentation today is sponsored by Wally's Lights. We want you to please don't unmute or interrupt the presenter. Make sure your cameras are in the off position. And I'm now going to introduce the Dr. Wizard, aka Merlin Q. Potter. He will be talking to you today about some lead strings and how they work and how they might fail and how we can repair them. He has been around for a long time and has a wealth of knowledge. And so I present to you Dr. Wizard, aka Merlin Q. Potter.
Good afternoon, everybody. I assume everybody's hearing me. Thank everybody for coming to this virtual Christmas summit and for coming to my presentation. So, all right. I know. I need to hit that key. There we go. Okay. So, this is about the regular LED strings. This is not about pixels or strips. They are topics unto themselves. But we're going to talk about the strings that you might buy at Walmart or Home Depot or even order from an online Christmas site. And so we're going to start off with how they work, how they're made, how they fail, and how to fix them. I know everybody's interested in part 4. The first parts will give you a little background so that when you get a really annoying string, you'll have some understanding. You can do some troubleshooting. And if we have time, and we really should actually, because they agreed to bump me up to 2 hours, we're going to talk about some modifications like making custom links, converting them to full wave, and retrofitting old incandescent strings. So my real name is Wizard, I swear. I also happen to have a PhD, so on the Christmas forums and most websites, you're going to find me as Dr. Wizard. Facebook, however, did not believe me when I tried to tell them that my real name is Wizard and wanted me to send them my driver's license and birth certificate and all kinds of other stuff. I don't trust Zuckerberg, so that wasn't happening. And I just made up Merlin Q. Potter. And if you were at the Florida Mega Mini last year, I was the guy with the hot pink hair. So I was the family light guy since I was a kid. I went all blinky, flashy in 1979 using a 4-channel mechanical timer that I salvaged out of an old Holiday Inn sign when they started changing their signs over. I built a TRS-80 based controller in 82. I got my master's degree in electrical engineering in 1983. I switched to lore in 2006 after seeing the viral Wizards in Winter video that was going around. So I was in on the ground floor with lore, and I switched to X-Lights a couple years ago, but I actually still really use Lightorama version S4 quite a bit. I'd use that for all my AC lights, and my show is actually more AC lights than pixels. So this is my show. I'm in Orange Park, Florida. I've got over 20,000 LEDs. I think somewhere around 190 channels, about 4,000 pixels. I have lasers, strobes, projectors, disco balls, and more. I have all kinds of weird stuff in my show. It's not just about Christmas, but we do the other holidays in December as well. And I welcome all faiths and beliefs and collect money for the local animal shelter. I got a page on Facebook, and then my own website is just bizlights.com. So, part 1, how they work. What is an LED? It stands for light emitting diode. I expect most people know that. What is a diode? If you're not an electrical person, they're usually semiconductors. They do have tube diodes. They're usually made from silicone or germanium. They dope the silicon or germanium with certain impurities which creates an N side or a P side, as they call it. It's the negative and positive ends, where you have extra electrons, or you have an absence of electrons, or holes, as they call them. The neat thing about diodes, which they're really used for mostly, is that they conduct electricity in only one direction. So they're like a one-way water valve. And besides LEDs, there's all different kinds. Rectifier diodes are common. You got tunnel, Zener, and the list goes on and on. Different specialty types. When you're looking at diodes, they really have three important specifications. You're looking at the voltage drop, the reverse voltage, and the forward current. Voltage drop is usually always the same for a certain diode, no matter what the voltage is or no matter what the current is. And that's a useful property, especially with the Zener diodes. And that's how they make voltage regulators work. So your normal infrared, red, orange, and yellow LEDs are typically going to have a voltage drop of about 2.1 volts. It varies a little bit, depends on who made it. And then your green, blue, purple, ultraviolet, white, pink, they're typically about 3.1 volts, give or take, depending on who made it. And if you're trying to do a quick back of the envelope calculation, you can just round that off to 2 or 3. So this is a little setup I did to kind of show you how voltage drop works. You'll see the left side circuit is 5 volts, the right side circuit is 12 volts, and yet the voltage drop in both cases at the red LED is 2 volts. So if you're eagle-eyed and you noticed I changed the resistor in that, that is not the reason that the voltage drop stayed the same. I just did that, because I'm trying to show you want to keep the current under 20 milliamps. And so reverse voltage, that's the maximum voltage that you can give to a diode in the reverse direction before it releases its magic smoke and possibly even start to fire. So you got to pay attention to that rating for other things. But for when you're working with holiday light strings, that's not something that we're going to need to be concerned with for what we're doing here. And then finally, the forward current. And this is real important on LEDs. The maximum amount of current that the diode can pass in its forward direction, again, without releasing the magic smoke. So they typically have a continuous rating, and they also often have a pulse rating. Most of our regular LEDs that we're going to run across in Christmas lights is going to have a continuous current rating of about 20 milliamps. Sometimes it's 25. Now, when they're pulsed, they can handle more than that, but you certainly want to keep the average below 20 milliamps. If you've got one of the higher powered LEDs, like in the floodlights, they draw considerably more current. Even if you're hooking LEDs up to something that is the same voltage as its drop, you still have to have a resistor to keep that current limited. Current versus intensity. An LED will actually produce about 90 to 95% of its maximum intensity at about 75% of the maximum forward current. And even at half the maximum forward current, they're still putting about 75% of the light out. And the human eye, which is looks at contrast, that's actually much more pronounced to the eye. So again, running at half current puts out 3/4 as much light and uses half as much power. The important thing is that makes them last a lot longer. You can see down there, I've actually got a chart that came off a data sheet, and it shows the relative intensity versus the current. Now, a lot of the LED light strings that you're going to run into, the engineers have set them to run it pretty close to the maximum current so they can get the maximum intensity out of them for marketing reasons. So, do we have any questions on the first part here? Can I give people a chance to unmute here?
We sure can.
Okay. Does anybody have any questions about the first part before we move on to the second part?
If anybody has questions, they can fire away right now.
All right. Well, it doesn't look like it. So let's move on to part two, which is how they're made. Okay. Do we have anybody here from a 240 volt country? So I can make sure to specify on some of these other things about voltages. Okay. So LEDs are made pretty much the same way they make all kinds of other semiconductors, transistors, and computer chips and all that. And I can't really go into how they're made. Actually, for a typical semiconductor, it takes over a year from raw material to finished product with over 1,000 steps. It's all pretty fascinating if you want to look it up, but basically the short version is they grow these silicon and germanium crystals, big ingots in foundries. They slice them into little thin wafers. They do the etching and the doping that we talked about earlier to lay out all the different sections. They do that by projecting it on there. They cut out all the individual LED chips. They attach them to a mounting thing and add wires to it. And then they encase the whole thing in epoxy to protect it. And the actual raw LEDs, the dyes, you put about 3,000 of them, give or take, on your thumbnail. That's how small they are. Colors. LEDs are available in a lot of different colors. The red, orange, yellow, the infrareds, they're normally made from aluminum, gallium, indium phosphide. By varying the amounts of each of those just slightly, they can control the color. The green, blue, and ultraviolet, they're made from indium gallium nitride. Again, they adjust the proportions to get the different colors. White LEDs are actually blue LEDs with some yellow phosphor on them. And so the colors combine and it looks white to our eyeballs. And by adjusting the composition and the chemical makeup of the phosphor, they can adjust that a little bit and make them warm or cool. Purple LEDs, the purple LEDs that we find in our Christmas light strings, they are actually blue LEDs with some red phosphor. And then the pink LEDs are also blue LEDs, and they add some fluorescent orange phosphor on top. All right. The LED colors look so intense because they're monochromatic. They only put out a single wavelength of light. The exceptions are those ones I was just talking about with the phosphors, which are white, pink, phosphor purple, ice blue.
These are dioptrous Phoenix mass. And now I want to start the process of dividing.
Okay. Not sure what that was. Of course, our regular incandescent bulbs, they just burn real hot. They make a wide spectrum of light, which we perceive as white when all the colors are mixed together. And then they put some paint on the outside of the bulb to get a colored one. The standard, easy to find colors for LEDs are infrared, and there's actually more than one infrared. Our regular red, pink, orange, yellow, green, blue. Ice blue is relatively new. They've only been around a few years. The ultraviolet purple LEDs is what you're going to find everywhere. They are monochromatic at 395 nanometer wavelengths. And then, of course, you got the cool whites and the warm whites. And some people call them daylight, natural white, and it depends on the manufacturer. There's actually at least 40 different colors available, though. And if you want to special order them and hunt them down and pay extra, you can get colors such as super deep red and super ultra green and royal blue and Of course, phosphor purple. RGB LEDs. Basically, three categories of these. There's the dumb ones that have no brains in them at all, and it's up to you to control the color with your own external circuitry. And they're just plain three LEDs in one. That's about all there is to them. Pixels, as I said, that's a whole nother matter, but they'll usually have four leads. The thing with them is they have power and ground, and they have data in and out. And a computer sends a signal to them and tells them what color to be. And you can have a whole string of them, and you can set each one to its own color. Of course, you still have to have a computer that sends the commands to them, but they've got their own internal little chip that interprets that and sets the colors. And if you're looking at strips, you see like the 2812B, the bullet pixels are made with a WS2811. And then last of all, we have the color changing LEDs. They've got a little chip in them that just makes them fade colors or flash colors. It's all pre-programmed at the factory. You can't change it. It just does what it does. But they're kind of cool. So let's talk about those purple holiday lights. The ones that you're going to find in the stores are not the UV purple that you would get from most electronic suppliers. They're the phosphor purple, as I said. They're the blue LEDs with some red phosphor, as I said. And they are really hard to find. And in fact, I spent quite a while and spoke to a heck of a lot of people before I even found out the official name for them was phosphor purple. And then once I knew that, then I had to speak to almost 20 manufacturers before I found one that would sell some to me. So their color is pretty close to, but not quite the same as the pink LEDs. And the pink LEDs are pretty easy to find. In a pinch, you can replace the purple with a pink. And if you've got lights with the colored lenses, you might not notice, probably won't notice. If you're looking, who is it that's not muted here?
They're all unmuted now. You're good to go now.
You're muted there, Doc.
Doc, just go ahead and unmute yourself.
Oh, there we go. There we go. Okay. Everybody hear me? If you're looking on eBay, AliExpress, wherever for purple LEDs, what you're going to find are those ultraviolet ones or near ultraviolet at 395 nanometers, and they don't match. In fact, the pinks are closer than the supposedly violets. So as I said, they're difficult to find. I finally tracked some down. I'm going to do a group buy direct from China. And if somebody wants to get some phosphor purple LEDs for me, my contact information is going to be here at the end. I lost my focus here. There we go. Whoops. Okay, so this is a photo I took to try and just show you that you actually have three different colors here. You can see that the phosphor purple is closer to the pink than the typical violet. They come in more styles and sizes and shape than you can even count. They come in two basic categories, though, and that would be the through hole, which has the wires sticking down, and the surface mount, which they put directly onto circuit boards. The round ones, the through hole, typically come in 3 millimeter, which they call T1, and 5 millimeter, which they call T1 and 3/4, and also other diameters, 8 millimeter, 10 millimeter. But the 3 and the 5 are the most common. They come in square and rectangular sizes for the surface mount, and you can tell real quick what size it is from its number. So a 50-50 is actually 5.0 by 5.0 millimeters. A 3528 would be 3.5 by 2.8. Those are two very common sizes. 0602 you'll see a lot, and there's way more sizes besides those. The lenses, we're going to talk about our through hole. You can get them round, square, rectangles, triangles, arrow shaped. Round, of course, is most common. They can be what they call water clear. They can be colored or tinted. They can be milky or diffused or frosted. You can get them in the typical round top shape, what they call a top hat shape, a straw hat shape, flat top. You can get them with Fresnel lenses on them. And another thing that's pretty interesting or important here is you can get them with or without the little flange at the bottom. And that's important to us. So, the straw hat shape is meant where you want to kind of focus it and have a beam. So we don't really want those for our Christmas lights. The round top, they're not bad. They have a much wider viewing angle, but they're still not really bright from the side. So if you can get the round top in the diffused or milky or frosted, that makes them a lot more visible from the side. Now, if you're putting them into, say, a chloroprop or something where they stick straight through, it doesn't really, you're not too worried about seeing them from the side, and the regular clear round top is fine for that. The best, but a little tricky to find, are the concave or top hat style. And the way they're shaped, they actually diffuse the light quite well in every direction. When you're buying LED strings, you'll see a lot of people talking about sealed LED strings, and a lot of people swear by them. What they've done with those is they've molded the LEDs directly into the plastic, and they are not removable. The great thing about them is they're more or less waterproof, and water is a big problem. So the leads on them don't rust out, and so obviously they tend to last a lot longer. Of course, they also cost more. You can't just pick them up at your local store. You got to order them from a Christmas light place online. And when an LED fails, you pretty much can't change it. Are they worth it? Because I said a lot of people swear by them. Well, it depends. If you're putting them up someplace where they're hard to get to, it's going to be a pain to try and replace them and repair them, then it might be worth it to save you the labor. And we're also going to talk about later how you can improve the water resistance yourself on your regular strings. Full wave strings, you'll see a lot of people talk about those. They include a full wave rectifier as part of the string. They can be brighter. The main thing is they have a reduced flicker because they're actually going at 120 times a second instead of 60. Or for our European guys, it would be 100 instead of 50. And that gives you smoother dimming. Again, they cost a good bit more. You've got to order them. You can't get them at your regular store. A lot of them you can't daisy chain. And because they're brighter, they may end up burning out faster. Hopefully not. Hopefully the engineer designed for that. The reduced flicker, the better dimming, whether it's you want to spend all that extra money, that's up to you. But we're also going to talk about in our part 5 how you can take a regular string and turn it into full wave. So the screw-in bulbs, these are awesome. If you got the money for it, this is the way to go. Just real easy to change the bulbs, even if you're up on the ladder at 11 o'clock at night. The strings are very easy to fix and modify. They have a very traditional look to them. They're bigger, they're considerably brighter, because actually each bulb contains 3 or more LEDs, and they are very versatile. The problem is, what they cost. Or some people might consider the size to be a problem because they are big. But they're really versatile. The nice things with these, you can put the sockets anywhere along the wire. so you can make custom spaced or custom length strings, put them around your windows, whatever. That are available white, black, brown, and green. There's all kinds of different mounting clips that you can get for them to stick them under the shingles, to stick them in your window frame. There's just all different shapes and sizes. And then there's all kinds of different bulbs available. So you can get the LED bulbs in at least 10 different colors in the screw-in style. Incandescent bulbs, more than 20 colors. You can get color changing bulbs. You can get all kinds of flashing and twinkling bulbs and the flame effect bulbs and bubble lamps and strobe lights and round ones and neon bulbs. And you can just mix and match however you want all up and down the string because they're all take 120 volts. And when we're talking about these, they have several shapes and sizes. The most common by far is the C shape, especially the C7 and the C9. Sometimes you'll see those called strawberry. The number is the size of it in eighths of an inch, or the old school incandescent lamps, the C7 actually draws 7 watts and the C9 draws 9 watts, unless they're eco bulbs or something. G shape, that stands for globe. You see them sometimes called raspberry because of, again, the texture that on the plastic they do. The number on those is the size in millimeter. There's the S-shaped bulb, and then there's the M and the T-shaped bulbs, and those are meant to look like the regular old incandescent mini lights. The T shape is smooth, and the M shape, has a texture on it. It's crystallized or diamond cut, they call it a lot of times. And again, the diameter is in millimeters. But you pretty much only find those in 5. So socket sizes, here in the US, we have the C7 uses the E12 base. E stands for Edison screw base. 12 is the diameter in millimeter, and they're also quite often called candelabra. The C9 is an E17 base. Again, same naming convention, and you'll see them called intermediate. And then the bulbs that you have around your house in your regular light fixtures, those are usually E26 or E27. Those of you over in Europe, some of the other countries, instead of the E12 and E17, for 220 to 240 volts, you may see the E14. So all these choices, what the heck do you get? Well, it depends on what kind of strings you have. You're probably not going to find a perfect exact match, but you're going to find something that's close enough no one's going to notice. For most of the strings, especially any of them that have any kind of lens on them, what you're probably going to want is the 3 millimeter or the T1 size, and you're going to want them flangeless, and that's important, and we'll talk about that in a bit as to why. You get the round shape. If you can find the concave top hat with the flangeless, that's the one to get. It's hard to find them that way. Diffused is preferable if you can find them that way. Colored is kind of nice if you can find them that way, but you don't have to have that. And the best place I found to get them is AliExpress. There's a seller called Mole Smell, and he has the 3 millimeter flangeless in quite a few different styles and colors. Then, of course, we have the 4-legged variety. This is my dog. This is Miss LED Pixel. Yes, that's her name. So, as I mentioned, I'm going to do a group buy of the phosphor purple LEDs for people that have purple LED strings and they want to repair their own. Probably going to be running around $6 to $8 a bag, I think, with postage. And I'm going to order them after talking to some people in the Florida Mega Mini. That's coming up May 1st. So I'll be ordering them later in May. And from China, I'll probably have them about June or July. And there's my email address. You can contact me if you want to get in on this. All right. So do we have any questions on part 2? Anybody questions about what type of LEDs they might want for a certain string or something?
No questions in the chat at all. If you have any questions, throw them in there. But so far, no questions. Doc?
Well, yeah, I guess I'm doing a pretty good job at covering all the bases. I was trying for that. So part 3, how do they fail? Okay. Critters and landscapers, they will chew and cut your wires. We curse them all the time. Causes of failure include critters and landscapers, and they will chew and cut your wires. Your kids, your significant others, unplug things. As the wind blows and your trees grow, that can stretch the wires and pull them loose. And of course, there's good old dihydrogen monoxide. That's our one of our biggest enemies there, and that causes rusted and corroded connections, blown fuses, tripped ground fault interrupters. If you don't know, dihydrogen monoxide is actually water. And the other big killer is heat, and that will cause your individual LEDs to fail. Heat is your enemy. Too much heat will kill all kinds of semiconductors, including LEDs. Semiconductors, the name explains what it does. It only passes part of the electricity. So that extra part has to get converted to heat, and that heat has to be dissipated somehow. LEDs, when they fail, they tend to do so in a shorted out manner. That can be good or bad depending on how you look at it. It means the rest of the lights in the string will stay on, but now they're each getting a little bit more power. And so that means they're going to overheat and fail sooner. And there's even a little chart you can see as more and more LEDs fail, the voltage and the current, which remember I said the current was important, you'll see the current goes up as you get more failures. So you want to check for failed LEDs often and replace them as quickly as you are able to. When you're looking at LEDs, they have 2 ratings, lifetime and reliability. So all your LEDs are going to slowly get dimmer over time. They have a lifetime rating, also known as the luminance maintenance life. And that is, on average, how long it's going to take before they fall below 70% of their rated output in lumens. Now, they're actually usually put out more than they're rated for, so they actually a lot of times drop about 50% of what they had when they were new. That's also known as the LM70 rating. And then, like most other electronics, they have an MTBF rating, mean time between failures. That's their overall reliability, and that's how long on average before half of them are going to fail for any reason, including that LM70. So blue LEDs, why do they fail so much? I bet everybody's noticed that, haven't they? Well, the short answer is they overheat. They're made from the indium gallium nitride, as I said earlier. Large quality crystals of this are really difficult to make, and they typically have a lot of imperfections in them. Those imperfections prevent the chip from bonding tightly onto the base, the substrate, which is synthetic sapphire, by the way. That poor bond prevents from getting a good heat dissipation. It's just like you don't have the heat sink on your CPU well. It's not going to dissipate the heat. And as we said, too much heat kills LEDs. This also affects the green, white, purple, pink, and ultraviolet LEDs because I said they're also made from the indium gallium nitride. So do we have any questions on this part?
There was one in the chat talking about those replacement bulbs.
What type of bulbs would you be looking for? What type of strings you want to put them into?
John, you can unmute yourself if you want to ask them the question.
Yeah, I was, that link that you had up just in the end of the other part had what I think are the ones I need.
You talking about the phosphor purple or
No.
something else?
No, you had put up a link about that one vendor that you
Oh,
were.
okay. So on AliExpress, the vendor's name is Mole Smell, and you can either search for that, or you can search for just 3mm flangeless LEDs. There are some other sellers besides him, but he has the biggest variety.
Okay, thank you.
Okay. Any other questions? Okay, so we're going to move on to the part I know everybody was waiting for, how to fix them. And again, this is going to kind of depend on what kinds you have. But you absolutely must have an LED keeper. There's no way around it. It's required. Around Christmas, you can get them at Home Depot and most of the big box stores. If you need one now, you can get them off of Amazon or most Christmas light websites. Do not use a light keeper, which is red. The LED keepers are yellow. Don't use the red one. The red one is made for incandescent bulbs. It's very different. It generates a high voltage pulse to fuse the little shunts on the bulbs, and that high voltage pulse will fry your LEDs, and all that magic smoke will get out. Other tools and supplies you'll need, and this is not a complete list. It depends on what you're doing. You're certainly going to want a voltmeter and or a non-contact voltage tester. They're pretty slick if you don't have one. You're going to want some nippy or flush or diagonal style cutting pliers, but the nippy ones are going to work the best for trimming the leads. Some regular wire strippers for the regular wire. I've been real happy with these Irwins that I've got. You can see the picture. They're $11 on Amazon. You can also order them from Lowe's, which carries the Irwin stuff. Soldering iron, if you know how to solder it, and the supplies that go with that, some flux and things. Or else you can use the solder sleeves. I know a lot of people like those. I'm kind of on the fence about them, but I like them for fixing things when they're on the fence. They're good to use out in the field. You'll probably want some heat shrinkable tubing, and you can get it in green, by the way. The 2mm usually works pretty good, or 1/8 inch. If your wire's a little thicker, you're doing some other splicing stuff, you might want some 3mm or even some other sizes. Hopefully you've got some of those. You've been saving all those spare tiny fuses that came with all your sets. If not, you can order them. You're going to need some spare LEDs, which we're going to talk about what kinds you're going to need. And some beer definitely kind of helps. So when you're troubleshooting, first thing is you want to get the scope of the problem. So is the entire string off? If the entire string is off, make sure it's getting power. Make sure the fuses haven't been blown. Check for any cut or chewed wires or that have been pulled loose. If only a section is off, well, then you probably have a bad LED or two. Maybe an LED has fallen out. You may have a rusted or corroded connection. That's pretty common. And again, you may have a wire loose. And if you just got a few LEDs off here and there, those are just bad LEDs. So the entire string is off as we were talking. Make sure it's got power. You'd be surprised how often that's the problem and you don't even realize it. Non-contact voltage tester is a real quick, fast, easy way to test that. Check your fuses and check for bad wires. I see someone's got, how about if the entire string is on but dim? Good question, actually. I didn't think to put that one in there. That's going to be a bad LED, or it's going to be a rusted, corroded connection. And I see question, do you use a sacrifice string to repair others? Sometimes. It depends on what the problem is. But we're going to talk about changing the LED bulbs, and that will save you some money, and you won't have to cut up or sacrifice as many strings to repair things. You will still need some sacrifice strings if you have like broken sockets and things like that. So yeah, if you got a string that you're having trouble fixing, throw it in a box and save it, and you can always use it for parts. Okay, so testing the fuses, and there's all kinds of quick, easy, different, dirty ways to do that. Somebody said he changes the whole section if you can't find the dead LED. Well, that's a way to do it. It's a brute force. We're going to show you how to track it down here. So your fuses, a quick, easy way, plug another string into the other end. If that comes on, you know your fuses are good. You can take your non-contact voltage tester, put it just a couple inches back from the plug, and if it lights up and beeps, the fuses are good. You can use a voltmeter and test on one of the female ends. Once you've taken the fuses out, you can test them in your LED keeper. It's got a little slot just for that. Usually you can tell just by looking at them. If they're black, they're bad. And you can, of course, check them with an ohmmeter. In fact, you can check them while they're still in the plug. So you check if they've got the plugs where the female is right on the back side of the male. You can check one blade in one slot and then check the other blade in another slot, and that'll check both fuses. Getting them out can be a real pain in the butt. You've got to slide open this cover on most sets, and it can be pretty sticky. You may have to fight it a little bit, but the trick I found is you put a pointy object like a little small screwdriver, a little jewel screwdriver, into one of the grooves or indents on there, and you push, and the cover will slide open. Then you have to pry the fuses out. Again, this can be a little annoying, but and again, a little small jeweler screwdriver works pretty well. A dental pick works pretty well. I found most cases easier to start from the back side of the plug, and then you could get it up at an angle. You can grab it with your fingers or some pliers. Put it back in is pretty much the opposite. You lay it in place. You push down on one end. You push down on the other end. And there you go. Repairing cut or chewed wires. If there's part of it's chewed up, you're going to cut that out. Put some heat shrink on there, don't forget, or a solder sleeve, don't forget. You're going to strip it and put it together. You're going to use what's known as a Western Union or a lineman splice. And there's a little diagram there that shows how it's done. And I even took some photos. So you cross them and then you twist them around each other. And that gives a lot of contact area and makes low resistance and high strength. Put on your heat shrink or your solder tube, melt it, shrink it, and there you go. You didn't forget the heat shrink, did you? If you've got to cut real close to a socket, well, you can't do one of those splices. So you've got some options here. You can remove the contact out of the socket and then reattach the wire to it. And we've got some info on that coming up. You can just take the socket out and replace it with a 300 to 330 ohm resistor if you don't really need the socket. Don't care about the light in that position. You can splice in a socket from a junk set, as someone was saying they keep their old sets. If it's just one socket, you can just splice it out and not really worry about it. It's like having one failed LED. It will slightly increase the voltage and current, but in a set of 35 per section, that's 3%. So if you got a wire pulled loose, what we're going to do is from the back side of the socket, you can take your small screwdriver and push the wire out. Again, this is why you might not want sealed strings, because you can't do that with them. Once you've got it pushed part way out, you can grab it with some needle nose pliers and pull it the rest of the way out. Strip your wire back a little bit, push it through the hole in the socket, and then you got to put it onto that terminal. And you got some choices here. I have found I can usually get the crimp part at the back open, but I can't get the crimp part at the front open. So I will use the back part to recrimp it and hold it in place, and then give it a dab of solder. That's what works pretty well for me. With some patience, you can actually usually even get the front part to unfold and uncrimp. If you solder it or if you recrimp it, just make sure it doesn't stick out too far. If it's too big of a connection, you won't be able to get your LED back into the socket. Once you fix that, you can just push it back down in. There's little grooves on either side that hold it all the way up against the side. So you need to make sure that it slides into those little grooves. If the socket's all chewed up, you can replace it with a 300 to 330 ohm resistor. If you want to replace 2 or 3, you could do, I think, what, a 6. I don't remember the values, but you multiply that. You probably don't really want to do more than 3 or 4 sockets that way, without rethinking how much current is going through the string, because that's not a perfect replacement, but it makes a pretty good substitute. So you put some heat shrink on, you solder your wire into place. You can do that with solder tubes, but doesn't work out as well. Ignore the color code in this because I couldn't find the right one in a hurry when I was shooting pictures. You solder it on, you put your heat shrink over it, shrink your heat shrink, and there you go. That's how you can replace a irreplaceable socket. Now, so say you've got to track down some bad LEDs or some bad rusted out connections. This is where your LED keeper comes in handy. And as I said, they are indispensable. The idea is you're going to divide and conquer. You're going to split the bad section into half. Find out which part works, and you split it in half again. Find out which part works, and so on and so on. You're going to keep splitting it in half until you've narrowed it all the way down to one light. So it comes with some purple clips. You put one on either end of the bad section. If you lose them, you can use clothespins or binder clips, whatever. But you mark your 2 ends. You go halfway in between, and you clip the LED tester onto the wire. It's got a little claw with a little pin that pierces the insulation of the wire to make the connection. And then it's got a fancy schmancy circuit in there that supplies just enough voltage and just enough current for however many bulbs are there. It automatically adjusts. And so one half or the other hopefully is going to light up.
Doc, we got about 10 minutes left for this first section, okay?
Okay, well, all right, well, that's fine.
Yeah, you'll continue on in the next section.
Yeah.
We have to change
Yeah,
hosts and streaming, okay? But
Oh, you changed the host too, huh?
yeah,
Okay.
Yep.
All right. If you put the LED keeper on there in the middle and either half lights up, unfortunately that is somewhat common. Well, first of all, it might not be piercing the insulation. It doesn't always make a good connection on the first try. You can try repositioning the wire just slightly and clamping it again. You try that 2 or 3 times, you can't get it to light up. You may have multiple problems in that section. So you just divide and conquer further. You move, maybe a quarter of the way down or so, or after 3 or 4 LEDs and test, and move down that string and you'll find out. Oh, somebody said they didn't realize the fuses were bad. That's why I said you want to check that first. If the whole string isn't working, and you're certain, absolutely certain that it's got power, then most LED strings have at least 2 sections. Some of them have 3 or even 4. Typically, they're between 25 and 35 LEDs per section. On the red ones, though, you might see occasionally some that are 50 per section, because they only take a lower voltage, so they can get away with that. So you want to find where each section starts and ends, and you just scan down the wire and you look for where it gets a little bit thinner, where it only has 2 conductors instead of 3. That's your spot between the sections. And so then what you're going to do is you're going to just troubleshoot one section at a time. Put your marker clip at that break between the sections, other marker clip at the end, and go at it with your LED keeper and divide and conquer. So yeah, let's take questions on this, and then we'll switch over to the second hour.
Yeah, if anybody has any questions, feel free to unmute and go ahead and ask some questions.
I see someone said red can go up to 70 LEDs per section. That's really pushing it. I have never actually seen that. You can get strings with 70 LEDs, but they're 2 sections of 35. If you're in a 240 volt country, I'm not sure if over there if they just put more LEDs in each section or if they just use a bigger current limiting resistor. I have a hunch they'd probably change the current limiting resistor. Can you troubleshoot dumb RGB strings with part of the string out? Your problem with a dumb RGB string is going to be one of 2 things. Either the LEDs have failed because they've overheated, or just worn out. And that certainly happens. I've seen a lot of that. But then also, if part of a RGB string isn't working from a certain point all the way down, that's actually going to be a connection. Most of the dumb RGB strings I've seen are 12 volts, so they actually have the LEDs are in sets of 3, but each set of 3 is all in parallel. So if one individual module goes bad, then the rest of them are going to keep working. Okay. Can you take the blob out inverter? Why don't the LEDs light when you feed them with a DC source? Actually, they will if you get the polarity correct. Flip the plug over, and they should work on a DC source. You have to be careful, though, because their sensors are designed for AC, which is a sine wave, and they work in, they're actually pulsed, and a DC source could possibly feed them too much current and cause them to have a short life. I don't think that would really be an issue, though, probably.
Are there any other? Yeah, okay.
The LED keeper needs to talk to me, huh?
Probably as good at break as time as any. Take a 5-minute break, Tom.
Yeah, it very well could be. I want to again thank the doc for his fantastic presentation. Not only is he a legend in here, a lot of the new people that if you don't know, there was another gentleman that was asking questions in the chat, and he is also a legend. Richard Holdman stepped in to kind of listen, and it doesn't matter how long you've been doing this, everybody learns something new, and I think you did a great presentation today, Doc. We also want to thank the Boscoyo Studio for sponsoring this, and again, Wally's Night Lights for this page. We're going to take a 5-minute break. We'll stop with the video, and We'll get ready for part 2 in about 4 minutes or so. It gives everybody time to take a quick break and get a glass of water. Thanks very much, Doc.
Part 2 is actually part 5.
Okay, well, you can continue on with part 5.
Hello, Doc.
Howdy.
I'm the inventor of the LED keeper. Want to let you know you did a great job.
Oh, well, thank you. I love your product. I actually have 3 of them. I keep one in the workshop. I keep one on the shelf by the light show.